Good morning, or good afternoon, as the case may be. I'm obviously not at Malloy with you today, but I'm there in spirit. I am putting together a series of videos so that we can continue to cover content while I am at home with COVID. So you should have a review book or get a scan of the review book, topic 2. I've also posted a link recently so that you could purchase it. If you have not already purchased it, you'll need reference tables, a pen, pencil, and an iPad because we will be doing some worksheets together. We're going to continue talking about chemical formulas, how to work with chemical formulas, how to write them given words, and how to name them being given symbols. So most of you should have that review book by now. You should read pages 25 to 30. It is keeping up with what we have been talking about in class. And do page 30, numbers 1 to 15, and show any kind of work in your notebook where applicable as we move forward. We'll be doing some of these pages together. You'll see this slide again as we move forward. So we looked at this table, polyatomic ions. These are charged particles formed by covalently bonded atoms that join together with usually metals to form compounds. Things that you may have heard of, like electrolytes, that kind of a thing. I've reviewed what a lot of their uses are, or where you commonly might find them in class with most of you. Just know that this is table E. If you have a compound with 3 or more elements in it, go to this table. Chances are you'll be able to name the compound found here. It's not anything that you have to memorize. This is where you should go. I know that the video that I posted yesterday covered some of these. Just be aware that this exists. I often tell people to say it out loud in the privacy of their own room. H3O plus is hydronium, Hg2 plus is mercury 1, and so on. Just so that you hear yourself say it so that it triggers a response. This is the table I should be going to, table E. 3 or more elements in a compound, this is the table to go to. So here we want to talk about how to work with chemical symbols and counting atoms. As you can see, the first bullet point, it says the coefficient refers to the number of molecules. So for the first example there, it says 2C6H12O6. That says that there are 2 molecules of glucose present in that description. And what we would do to solve that is treat it like a algebra problem and distribute the 2 through the 6, the 12, and the 6. We'll do that in a moment. If you have, in the second bullet point, a subscript after a set of parentheses with something inside the parentheses, that 2 only goes immediately through the thing in front of it. And if nothing is written as a subscript for any element, it's understood that that subscript is 1. So for these examples, it says determine the type of compound and number of atoms of each element for each compound. So the first compound is glucose, and this is a covalent compound. I know it's a covalent compound because these are all nonmetals. So this is covalent, non-metals. Well, that's terrible, but gives you the idea. Calcium hydroxide, this is a metal attached to a polyatomic ion. The OH is listed in that table E, so this is an ionic compound. And the last one is an ionic compound also. It's the same one, but with a 2 in front of it. So let me get to my pen here. My pen and erase all the ink on the slide and go back to my pen so that we can do the math here. So if I want to know how many atoms there are in this first compound, it's 2 times 6, which is 12. I apologize for the shaky camera. I'm writing on my screen. 2 times 12 is 24, plus 2 times 6 is 12. So add all of that up. There are 48 atoms in 2 moles of glucose. So this is simply a distributive property. 2 times 6, 2 times 12, and then 2 times 6. That isn't so hard. The next one says it has a subscript. Now this subscript says it's a little different. You don't multiply, the 2 doesn't get distributed through everything here. The 2 only gets distributed through the H and the O. So there's 1 calcium atom, and then I look here, there are 2 oxygen atoms, and then I look through here, and there are 2 hydrogen atoms. So altogether, this is not higher math, there are 5 atoms present in 1 formula unit of calcium hydroxide. I say formula unit because it is an ionic compound. I don't refer to it as a molecule. So using the work that I did before, there's 2 ways you could do this. One way is distribute this through, the best way to do it is what we did before. 2 times the 1 hydrogen is 2. 2 times the 1 oxygen is 2. So far 2 plus 2. And then there's 2, and then there's 1 calcium. But there's still a 2 outside of this. Don't distribute that through to the end. So that means that this is going to be 5 altogether atoms in one of these, but I'm saying that there are 2 calcium hydroxides. So that means there are 10 atoms altogether. Okay, so that is how you would do problems like that, counting atoms. We will look at some sample problems together if you didn't quite get that. So, quick review, a molecular compound or when nonmetals combine, that's hydrogen and most of the nonmetals on the right-hand side of the reference table. They share outer electrons. Water and methane are examples of molecules. Ionic compounds are when a metal or nonmetal and possibly a polyatomic ion join together. They form by transferring electrons, and we refer to their formula as a formula unit. That's the correct way. You should get a hold of your review book at this point, or get a photocopy of the review book from somebody, or scan it. Use your phone to get images, pages 25 to 30, and on page 30, we'll look at questions 1 to 15 together so that you have a clue on what to do with these. So let me just get to a whiteboard here. On my taskbar. And this is that page, page 30. So these questions we'll look at together. You know what? We'll look at the We'll look at the odd problems together, and then you can finish the even ones on your own, and I will post the answers to the even ones. So the odd problems on this page, number 1, in a sample of barium nitrate, BaNO3, taken twice. When you have that 2 outside, you can say taken twice. The ratio of barium to nitrate ions is, well, the assumption is that you understand that there is a 1 implicit here. So that means that this is a 1 to 2 ratio. That is your answer for your first question. Number 3, which formula represents a compound? A compound is 2 or more elements chemically combined. So I'll give you a second. It should be choice 3. Number 5 is an example of those counting atoms. So how do we count the atoms? So it says, what is the total number of sulfur atoms in the formula NH4 taken twice SO4? So this is called ammonium sulfate. We will learn how to name these in a little bit. So I am going to go to the whiteboard on the side over here and rewrite this. NH4 taken twice SO4 sulfate. So if you remember what I said, if there's a number outside of a parenthesis, it goes back through whatever precedes it, kind of a distributive property. 2 times 4 is 8. There's nothing written here. It's assumed to be 1. 2 times 1 is 2. So in the first part of this, there's 2 and 8. And then there's 1 sulfur. It's implicit. 1 sulfur and 4 oxygens. So 2 and 8 is 10, and 1 is 11, and 4 more. There are 15 atoms present in that. Okay? So, and actually, they're only saying what is the number of sulfur atoms present, and all you have to do is answer is 1. But that's if you had to figure out the whole thing. I've got COVID head. I apologize. Let me erase this so that we can get ready for another problem. Wouldn't let me erase all of that in one shot. Sorry. It's always challenging to try to learn a new technology while you're home feeling miserable. Okay. Let us look at number 7. An example of an empirical formula is. An empirical formula is the reduced form of a formula. So which of these is reduced as far as it can go? This is not reduced. It can be reduced by 2. This can be reduced by 2. This can be reduced by 2. So choice 4 is the empirical formula in this example because it can't be reduced anymore. It already is reduced. And Number 9, what is the empirical formula of a compound with the molecular formula C6H12O6? Well, if we look at these subscripts, they're all divisible by 6. So this can be reduced. So if I divide 6 by 6, I get a 1. If I divide 12 by 6, I get a 2. If I divide 6 by 6, I get a 1. So the empirical formula of this would be right here. Number 11, the empirical formula of a compound is CH2. The molecular formula of this compound could be, well, they want you to go in the other direction. What was it before it was reduced? So if it's CH2, it's got to be multiples of this. So it could be C2H4, it could be C3H6, anything where whatever it was before it was reduced. So the best answer for that one would be C2H4. Let's look at the next one. Number 13. For each of the following formulas, write the name of each element and the number of atoms of that element that are in the formula. So I'm going to start with what seemingly is the more difficult of them. I'm going to start with a number. Yeah, I'll start with number 13C. You should be able to do A and B. Those are simple ones. And then I'll do I'm going to look at 14C as well. So 13C, let me write that out over here. Fe2 SO4 taken 3 times. Excuse me. Well, that is Fe is iron, S is sulfur, and O is oxygen. So this is iron, sulfur, and oxygen. Now, using the rules, the 2 is a subscript for iron, so there are 2 iron atoms in that altogether. If I go from left to right, the way we read, and then I look, there's a 3 outside of this parentheses. There's understood to be a 1 there, so 3 times 1, there are 3 sulfurs. If I look at the oxygens, there are 4 oxygens in the polyatomic ion. 3 times 4 is 12. So when we come down to, and if I add all of that up before I come down to it, I have 2 and 3 is 5, and 2 more is 7. So I have 17 atoms altogether in that compound. If I have 17, let me just clean this up a little bit here. So I have 17 atoms altogether in the compound. You haven't learned how to name it yet, but this is called iron 3 sulfite. So for 14C, since I've already figured out that there are 17 atoms present in one formula unit of Fe2SO4 taken 3 times, you would simply multiply whatever I got there, the 17, by 5, and that would tell me that I have 5 times 17, so that's going to be a 5. Carry the 3. 5 times 1 is 5, and 8, so 85 atoms in 5 of those. Okay, I hope that that was helpful. You definitely need your review book and your iPad for the next few days so I can present this. Hopefully, I will get better at the whiteboard as we go along. I will still try to answer emails up until 8 o'clock as much as possible. This thing is wiping me out a little bit. As you can tell, my voice isn't where it should be. So hope you're well and hope you avoid this. Have a good day, gang.